Hi Math 30s. This video is going to be the first part of lesson number 3 on permutations and combinations, and it's going to be looking at permutations with restrictions. In class example number 1, it says, in how many ways can all of the letters in the word oranges be arranged if? So if you count up the number of letters in oranges, there are 7, and they want to know how many different arrangements can we make using those 7 letters if there are no further restrictions. So according to the fundamental counting principle, how many 7-letter arrangements can we make? There would be 7 stages. And how many choices of letters can go into that first stage? There would be 7, and then 6, 5, 4, 3, 2, and 1. You could multiply that into your calculator, or you could enter 7 factorial. 7 factorial is going to be 5,040. So using, again, just the letters in the word oranges, there's 5,040 different arrangements that could be made. The other way that I could illustrate this, so I could illustrate it using factorials, I could illustrate it using the fundamental counting principle, or I could write it as a permutation. So remember that a permutation is n permute r. So in this example, the number of elements or the number of letters is 7. And how many am I arranging or permuting? It would be 7 stages. If you typed in 7 permute 7, again, you get 5,040. B is going to introduce our first restriction. So it says, how many arrangements can the letters of the word oranges be arranged if the first letter is an N? So again, set up your 7 stages. The restriction that needs to be dealt with first is they want the first letter to be an N. So in the word oranges, there is only one N to choose from. So that would go in that stage there. Once that N is placed, we have 6 remaining letters to choose from to go there, followed by 5, 4, 3, 2, and 1. Again, you could enter that descending sequence into your calculator, or you could simply enter 6 factorial. And 6 factorial is 720 different arrangements can be made using the letters in the word oranges, and they will all start with an N. C is going to be new, and it's going to be important, and it's harder to sort of grasp this, but once you do several of these or a few of these, you'll understand. So what it says is the vowels in the word oranges must be together in this order, O, A, and E. So in the word oranges, there's 3 vowels. So I'm just going to write the word. And it wants the 3 vowels, O, A, and E together. And so what I tell students to do is place those 3 letters on a disc. So create a disc, and we're going to put the letters O, A, and E. The remaining letters you're going to put on separate discs, okay? So O, A, and E have been placed. So then I need a disc for the letter R, N, G, and S. Okay, and the reason why I'm putting them on like these 3 letters on a disc is because, again, it said these three letters have to be together. But then I could place this disc and I could start with the O, A, and E, or I could put it in between the R and the N, or I could put it here. All these discs I could move around. So how we would deal with this is if you have 5 discs, the answer is going to be 5 factorial. 5 factorial is 120. So there's 120 different arrangements that could be made, and the 3 vowels would be together in that order. Sort of thinking about this with the fundamental counting principle, I would have 1, 2, 3, 4, 5 stages. And then how many choices can I have to go into this first stage? Well, it could be this OAE, it could be the R, the N, the G, or the S, right? So that would be 5 choices. Once I place one of those discs, then I have 4, 3, 2, and 1. So again, 120 different ways. Class example 2 is going to be very similar to C with one exception. Okay, number 2 says, in how many of the arrangements of the letter the letters in the word brains are the vowels together. So first of all, in brains, we got to figure out what the vowels are. So it's A and I. So if we're doing this disc method, you put those, what they want together goes on one disc. So the vowels A and I would go on one disc. The remaining letters go on the remaining discs. So I'm going to have a disc with a B, an R, an N, and an S. Okay, that would be 5 factorial because there's 5 discs, so that would be 5 factorial. We know from above that 5 factorial is 120. How this is different from the previous example is it said the vowels need to be together. Okay, so the vowels must be together, but it didn't say in this order. Whereas in this example, they said they want it in the order O, A, and E. What that means this, or I could have the I, A first, and then the B, R, N, and S. Again, that gives me 5 factorial, which is equal to 120. We know that in an OR situation, we would add, right? So 120 and 120 is there's 240 different arrangements that could be done using the letters in the word brains where the vowels are together, but it doesn't say in which order. Now, instead of setting up as an OR situation, I'm going to show you how to set it up where we're just using factorials. So for this question here, here's what I want you to do. You're going to put what they want together again on a disk. So AI. Then we've got our remaining disks, which is B, R, N, S. We know that this is 5 disks, which would be represented by 5 factorial. Then what we have to take into account is this disk here, and we don't know if it's AI or IA. So how we account for this disk is how many letters do we have, which is 2, and you're just going to multiply that 5 factorial by the number of letters on that disk factorial. Because again, it could be AI or IA, which is 2 different ways, which would be 2 factorial. Okay? 5 factorial is 120 times 2 factorial would give you 240 different arrangements. Again, if you're not quite sure what I did here, you're going to see this again in class example 3A. So let's look at 3A. Okay, it's of the letters in the word kitchen if. Okay, so kitchen has 7 letters. So let's just jot that down. They want the letters K, C, and N. They must be together, so they are going to go on one disc, but not necessarily in that order, right? So K, C, N must be on a disc. Let's create our other discs of the remaining letters. So if K, C, and N are gone, then I would have I on a disc, T, H, and E. Okay, so this is the total discs that I would have. So that's going to be 5 factorial because I've got 5 discs, 5 factorial. But then we have got to account for this disk. It didn't say K, C, and N could be in that order. So how many different ways can you arrange K, C, and N? Well, K, C, and N are 3 letters. So the number of ways that you could arrange 3 letters is 3 factorial. You multiply that always by the number of total discs. So 1, 2, 3, 4, 5. 3 factorial times 5 factorial is going to be 720 different ways. If there's a homework question that does this, I will help you set that one up if you're still a little bit unsure. Okay, class example B. Again, this is going to be something new that we haven't seen before. It wants to know how many different permutations or arrangements can we make using the letters in the word kitchen if the vowels are not together. So it is difficult to figure out how many different ways that we could do this when the vowels aren't together. So what we do in math is we do something called the complement. And the complement of the vowels not being together are actually putting the vowels together. So what we're going to calculate is we're going to calculate the complement. And what we need to do is we need to figure out the number of different ways with no restrictions with the word kitchen. Once we have the number of ways where there's no restrictions, then we subtract from that the number of different ways where we do the complement. So the complement of the vowels not being together are putting the vowels together. Because if I subtract the number of ways the vowels can go together from no restrictions, that will give me the number where the vowels will not be together. Okay, so the number of ways where there will be no restrictions, kitchen has 7 letters. If I could arrange those in any way with no restrictions, that's going to be 7 factorial. Minus, now I have to figure out the ways with the vowels together. So the vowels in kitchen are I and E. So they go on one disc. Then I've got the remaining letters on different discs. So I've got a K, T, C, H, and N. Okay, within kitchen, if the vowels are together, that would be 1, 2, 3, 4, 5, 6 different discs. And then remember, it didn't say that they have to be in that order, so there's 2 letters on that disc, so that would be 2 factorial. So the total number of ways with no restrictions is 5,040 different ways that the letters in the word kitchen can be arranged. I have to subtract the number of ways that the vowels would be together, which would be 2 factorial times 6 factorial. So there's 1,440 ways that the vowels would be together. If I subtract those two numbers, that gives me 3,600. That's how many different ways there would be where the vowels would not be together. Because if there's 1,440 ways out of 50/40 that they'd be together, then the remaining would be not together. Okay, so this is called the complement. Class example 4. In how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender are sitting together? So we're going to set this up in stages. 3 girls and 4 boys. That would be 7 stages. If no 2 genders can be together, that's going to be like saying girl, boy, girl, boy. You need to look at this, the number of girls and the number of boys. So you need to say to yourself, would you start with a girl or would you start with a boy? If we have 4 boys and 3 girls, you're actually starting with boys. Okay, so a boy is going to sit here, 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 and here. So that's going to be 4 boys. And then the girls, I have 3 girls. Okay, so this is how many, from the 4 boys, how many boys do I choose from that could possibly sit in the first stage? There are 4 boys to choose from. Once one of those boys are placed, there'd be 3 boys that could sit there, 2 and 1. For the number of girls, how many girls can possibly go into that position there? There are 3 girls. Then there's 2 remaining, and then 1. You could multiply all that into your calculator, and you would get 144 different ways. Or how you could enter it in other ways on your calculator is 4 times 3 times 2 times 1 is simply 4 factorial times And then the girls would be 3 times 2 times 1, which is 3 factorial. 4 factorial times 3 factorial, that is going to give you, again, 144 different ways that 3 girls and 4 boys could be arranged where no two people of the same gender are sitting together. Class example 5. 6 actors and 8 actresses are available for a play, but the play only is going to have 4 male roles and 3 females. Okay, so how could we illustrate how many different cast lists are possible? So setting up using the fundamental counting principle, this play is going to have 4 roles for males and 3 roles for females. For the 4 male roles, I have 6 actors to choose from. So for this position here, right, for this role here, there's 6 different actors that I could select from. Then there'd be 5 remaining actors for that role, 4 and 3. For the females, I've got 3 positions to fill. There are 8 female actresses to choose from. So for the first position, I have 8 actresses to choose from, then 7, then 6. You could multiply that in your calculator and you would get 120,960 different combination of cast lists would be possible. Or the other way you could enter this is in permutations, the n permute r. So for this one, there are 6 actors available, and we're permuting 4 different spots or 4 stages. Times, for the actresses, there were 8 actresses available, and I'm arranging 3 different roles or stages. And if you typed that by this into your calculator, you would get the same answer of 120,960. So here's your homework for this first set. It's going to be, or for the first part, questions 1 to 5. I'm actually going to do a few questions with you, just if you were unsure about a few things. So let's go and let's look at some of this. Okay, so for example, for this one, how many different arrangements could be made of the word uncle if the C is first and the L is last? So again, uncle, 1, 2, 3, 4, 5. 5 stages. They want the C first, that's a restriction. They want the L last, that is a restriction. There is 1 C and there is 1 L. Then, how many remaining letters can go into this stage here? If uncle has 5 letters and I've placed 2, I would have 3 available, 2, and 1 last one available there. That would be 3 factorial, which is equal to 6. Okay. Daughter, so this one. So how many different ways can we arrange daughter if UG is last? So 1, 2, 3, 4, 5, 8. So 8 different stages. They want UG to be last. There's 1 U and there's 1 G. If daughter has 8 letters and I've placed 2 of them, I have 6 remaining letters to choose from to go there. 5, 4, 3, 2, and 1. So 6 factorial would give you your answer. B, mother if the vowels are first and last. So mother has 1, 2, 3, 4, 5, 6 stages. The vowels are O and E. They want the vowels to be in first and last. So how many vowels do I have for this position here to choose from? Two. Then I would have one remaining vowel there. And then I would say, well, how many letters? So 6 letters in the word mother. So once I've placed those 2 letters, 6 minus 2, I'd have 4 letters left to choose from to go there. 3, 2, and 1. So that's going to be 2 times 4 factorial. And 2 times 4 factorial is 48. I'll do one from number 2 where vowels are kept together. So that's going to be the disc question. So in the word daughter, the vowels are A, U, and E. Okay, so A, U, and E are the vowels. They go on one disc. The remaining letters go on the remaining discs. So I'd have a D, a G, an H, a T, and an R. How many different arrangements can I make from the letters in this word if these vowels must be kept together, so they're on one disc? I count up the number of discs after I've created them, and that would be 6. So there's 6 discs, which is 6 factorial. Then you take into account that it didn't say in which order these 3 letters must be, so there's 3 letters, which is represented by 3 factorial. You multiply that together and you are going to get 4,320 different ways. Okay, so you could do number 3. Okay, let's look at number 4 together. Anna, Brian, Colin, Diane, and Eric go to watch a movie and they sit in 5 adjacent seats. So adjacent is just side by side. We're going to use the letters A, B, C, D, and E. In how many ways can this be done if Brian sits next to Diane? So that would be like vowels being together. Brian and Diane have to be together. Then there's going to be Alice, Colin, and Eric. Okay. If I put Brian and Diane on one disc, and it doesn't matter where I put the disc, they will always be sitting together. So how many different arrangements can I make? I have 4 discs. And it doesn't say if it's Brian, Diane, or Diane, Brian. So there's 2 people on that disc. That would be 2 factorial. That's going to give you 48 total ways that those 5 people could be arranged. Those 2 will always be together. B is a complement question. Okay, so Anne refuses to sit next to Eric. What that means is you want to figure out what the complement is. The number of restrictions minus put Anne and Eric next to each other. Okay, so again, how you figure out a complement is you're going to figure out the total number of ways with no restrictions. So if there's no restrictions, there are 5 different people. That would be 5 factorial. There's 120 different ways that those 5 people could be arranged sitting beside each other. Then I'm going to subtract the number of ways and I'm going to put Anne and Eric together. Okay, so the number of ways where Anne and Eric are together. So what that would be, if Anne and Eric are together, they go on one disc. Brian gets a disc, Colin gets a disc, Diane gets a disc. That would be 4 factorial. I have to multiply that by 2 factorial. That's going to be 48 different ways that Anne and Eric would be together. So the total arrangements with no restrictions is 120 different ways. If I subtract the number of ways that Anne and Eric are together, which is 48, What would be remaining is the complement, which is going to be then Anne and Eric not together, which would be 72 different ways. Okay, we'll do number 5. In how many ways can 4 adults and 5 children be arranged in a single line without restrictions? So we've got 4 adults and we've got 5 children. They're going to be arranged in a single line. So that is 9 people. I could do the fundamental counting principle, right? Set up 9 different stages. And I've got 9 choices of individuals that can go to that stage. 8, 7, 6, all the way down to 1. So without restrictions, it would be 9 factorial. And 9 factorial is 362,880 different ways that 4 adults and 5 children could be arranged in a single line. B says if children and adults are alternated. So set up your 9 stages. If they're alternated, this would be like the boy-girl question. Who would be on the end? Would it be the child or the adult? It's whatever you have more of. So there's 5 children. So it's going to be children on the end. So there's my 5 children. 1, 2, 3. There's my 4 adults. Okay, so if they're alternating, how many choices of children can I put into this first stage? Well, there's 5 kids to choose from. Then 4, 3, 2, and 1. So that would be 5 factorial times. For adults here, there are 4 adults to choose from to go into that spot. Then 3, 2, and 1. 5 factorial times 4 factorial is 2,880 different ways. C, if all the adults are together and the children are all together. So remember, when something's together, put them on their discs. So all the adults together would go on one disc. So I've got adult 1, 2, 3, and the 4th adult. The children are together, so they're on a disc. Okay, that is 2 different discs, so that's 2 factorial. However, it didn't say that all the adults are together in that order, right? So the adults, I don't know, like this adult 1 could be over here or in the middle, like it doesn't say. So if there's 4 adults, the number of ways that those 4 adults could be arranged would be 4 factorial. With the children as well, it didn't say the children are lined up in this order. So there's 5 different children to choose from, so they could be lined up in 5 factorial different ways. And if you multiply that together, you are going to get 5,760 different ways that in a single line, all the adults and all of the children would be together. Last one. If all of the adults are together, okay, so all of the adults are together, they go on one disc. It doesn't say the children are together, so remember, if they're not together, they get their own discs. So the children, there's 5 of them. So the children get their own discs. There's first child, second, third, fourth, and fifth. So again, if all the adults are together, this represents all of the adults being together. How many different discs total do I have? I have 6 discs total. And then you have to account for the adults could be arranged differently than this, and there are 4 adults, so that's going to be 4 factorial. 4 factorial times 6 factorial is 17,280 different arrangements.